So, organic chemistry. What is organic chemistry? Well, it's the chemistry of organic compounds. And what are organic compounds? Well, of course, a lot of times you hear somebody say they contain carbon atoms. Well, that's not true because carbonates are not organic compounds. Carbon dioxide is not an organic compound. There's various other definitions bandied around. I prefer the one that says you've got to have at least one carbon-hydrogen bond. So what this means is that when we're thinking about organic chemistry, we can think about any organic compound as being single bonded carbon-hydrogen bits, so that's what makes them an organic compound, and then the appropriate functional group. So for example, ethanol, which is a carbon compound you've seen a lot, there is structure. I trust you're familiar with that. Well, if I look at this, I can see there's the single bonded carbon-hydrogen bit there in green. And that's generally boring and unreactive. We'll talk a little bit about the reactions of those carbon-hydrogen bits in a little while in a future movie in this particular module. But by and large, those carbon-hydrogen bits are boring and unreactive. The real fun part with organic chemistry comes with the functional group, okay? Because that's the bit that does the reactions. However, I should point out that the boring and unreactive single bonded carbon-hydrogen bit can affect the products that you get of reactions, and we'll talk about that in considerable detail as we go through the course. But by and large, organic chemistry is designed to talk about the functional groups. It's driven by the differences between what the functional groups do, what reactions they do. And that driving by the functional groups even comes down into the naming part of it. As I'm sure you know, but we'll talk about on the next slide, the eth refers to the boring old green single bonded carbon-hydrogen bit, and then the ol there refers to the alcohol. Now, as we go through, we're going to have various different ways that we depict molecules. And so I'm going to depict two different molecules in many, many ways over this next slide. First of all, let's stay with ethanol, okay, which you could write with its molecular formula, C2H6O, 2 carbon atoms, 6 hydrogen atoms, and an oxygen atom. Really wonderful if you want to like calculate the molar mass of it or something, but otherwise gives you absolutely no information whatsoever. At the other end of the information scale is the full structure. Some people call it the displayed structure. And what you can see here is that we show every single atom, obviously, but also every single bond. We even detail excruciatingly all that carbon-hydrogen single bonded bit. So a lot of times one will take organic compounds and will actually write it in a short, just using letters and numbers way to emphasize the functional group. So what I would call the functional formula. So you can see I've broken out the boring C2H5 bit from the OH interesting bit. A lot of times you will also see this expanded out a bit, which ironically called a condensed or shortened structure. You'll see where that comes from in a minute, in which we actually give the details of the boring carbon-hydrogen green bit there. Now we call that a condensed or shortened formula because it comes from a condensed structure. In a condensed structure, we don't depict every single bond, but we don't lump all of the carbon-hydrogen together. Instead, we put it in terms of little carbon-hydrogen groups. So you can see we got this carbon here with 3 hydrogens, this one here with 2 hydrogens, and then again, making it very clear there's the important little bit there. And of course, the ultimate in brevity that you will see an awful lot, and I'll use it quite a bit, but I will actually dip in between all of these except that one, depending upon what I need to show you. But the really sort of shortish, the least possible way you can give all the detail you want is the skeletal structure that would look like this. Now I trust you've seen this before. Essentially every end bit or junction bit refers to a carbon atom, unless there's an end bit that's got a fun group on it there. So we know we've got a carbon atom here, we got a carbon atom there. And if you're one of those funny people who likes to count hydrogens, you know carbon always has 4 bonds. This carbon here, we've got 1 bond from it, which means there must be 3 hydrogens. This carbon here, there are 2 bonds on it already, which means it must have 2 hydrogens. So we've gone from ultimately this extremely informative but a lot of times just too much detail, all the way down to this little skeletal structure. Let me do it for one more molecule, so-called 2-chlorobutane. Don't worry about the names. We'll talk about the names as we need to talk about the names. But 2-chlorobutane looks like this. Okay, you can see we got a chlorine atom there. That's where the chloro comes from. The bute, as we'll talk about in a minute, is 1, 2, 3, 4 carbons. I'm sure you already knew that. And the ane tells us that there's nothing else interesting in this at all. All of the carbon-carbon bonds are single bonds. So anyway, there is a nice little molecule of 2-chlorobutane. Now I could just give you the molecular formula. Again, absolutely wonderful for calculating molecular mass. In this case, the functional formula looks exactly the same. Okay, and so you'll have that sometimes where the functional group is just a one atom, like in this case, the chlorine there. And of course, if I wanted to put the condensed or shortened formula out, then I'd have CH2, CH with a Cl on it, CH2, CH3. Okay. Now let's go to the actual one where we show some bonds. Might want to practice there doing the condensed structure if you want. Again, we see the carbon, the boring old carbon hydrogen chain here with 4 carbon atoms, CH3, CH, CH2, CH3. And then of course we make it very clear we got the chlorine there. And the skeletal structure comes straight from that. 1, 2, 3, 4 carbon atoms, 1, 2, 3, 4 carbon atoms, not bothering with any of the hydrogens, but making it clear there is our functional group. Okay, different teachers might have different names for these different structures, but I will be using them in different ways. Make sure you can go from one to the other quite happily. One of the big tricks in organic chemistry is for the student to realize exactly how the instructor is drawing a particular molecule.